Hello and welcome to this session with the CAD Guild. We will discuss the infrastructure used by DevOps-enabled teams. We have servers that we use to implement the philosophy of DevOps. We need a version control server, CI servers, deployment servers, and containers. There is a range of servers to choose from that we can use to host our version control system. It may be Git or any other tool. We need the server to provide CI or continuous integration functionalities. Now, let's explore something more about CI. In CI, you need to provide a Jenkins server to run your Jenkins applications. Then you will have to provide build servers, test server, and will have to manage them as well. You might even have some specific requirement of server. For example, if you have to package your product in a particular way, then you need to install those tools on a particular server, and that can be added here. Then you will have a deployment server. Let us say that you want a web application to be deployed. For this, you may need a Tomcat server or want to have a WebSphere server or some other web tool. For your tertiary or intermediate containers, you may want to have a server which runs Docker. It is easy to get the hardware for the servers which you can buy at a standard server class machine. You can have a VM configured for you from your operations team. But you must keep in mind that the software that you install, especially on the operating system, plays a crucial role in how successful you will be in implementing DevOps. In this module, we are going to talk about the operating system that you should use for DevOps. We generally use Linux. Linux is the OS of choice for almost any server management team. Using Linux, you will have to deal with server management and operation in DevOps. Now, let us explore a brief history of Linux. Linux started or got its inspiration from Unix. It started in 1991 by Linus Torvalds, which I think you all know about. Linus Torvalds started this as a hobby project which has grown into a full-fledged operating system and is the only operating system known for server-class infrastructure. So why do we use Linux? There are a lot of advantages associated with Linux. First of which is it is free and an open source software. Companies prefer free software, and when you have an operating system like Linux freely available, then why not use that? The second advantage is its stability. Linux as an operating system is highly stable. I have seen Linux machines running for continually around 5 years. If you check the uptime of those machines, it has been running for 5 years, never been restarted. It does not mean that there was no problem in those machines. You might have to restart services sometimes or kill some processes, but it does not require a full-fledged system restart. So your system uptime is quite high, unlike Windows or any other infrastructure server operating system. Another advantage is that it is easy to debug. You can have quite a deep level of logs available for almost any application running on Linux to debug, and Linux provide a lot of open source tools to analyze the logs and identify the potential problems. Another advantage is the external security threats. Linux is designed around security. All of the file system permission or the user management is highly secure, and there is almost no viruses or malware reported on Linux. These are various factors that make Linux secure and reliable, and teams prefer to go with Linux. Now, let's have a look at some of the disadvantages of Linux. There are no disadvantages which may be a deal breaker. However, a few disadvantages include the high maintenance. The maintenance is not high in terms of hardware requirements or monetary expenses, but the maintenance is high as the engineers supporting this operating system should be well versed with it, and it is not an easy task to explore and to get into all the options available with the Linux operating system. This requires them to know a lot of command line, all the places where files are stored, how to get these files, where to look for problems, or where to look for hints for problem solution. Learning curve appears to be quite big for any DevOps engineer or any infrastructure engineer who might start supporting Linux. Windows Server, on the other hand, are GUI-based and possess Windows or Microsoft tools available for debugging. People prefer that for ease to use, but the GUI, as a matter of fact, takes away a lot of flexibility. Thus, a high maintenance may be a discouraging point, but not a showstopper point. Another point is that there are a lot of flavors and a lot of distributions which are in short referred to as distros. You might have heard of Ubuntu, CentOS, Red Hat, right? Hundreds of several other Linux flavors are available. So which one to choose? You cannot go wrong with any of them, however, you have to make a choice. The most popular operating system for server cloud infrastructure is CentOS. It is free for distribution without costing any money and is delivered by Red Hat. Most of the people go for CentOS as it has a proven background and is backed by a company which is well known in the world of Linux. These are some minor inconveniences, I would say, in Linux. Now, let us find out what Linux is made up of, or what does Linux architecture look like. Linux operating system. In fact, all operating systems look like this. There is a kernel in the center which takes care of communicating with your hardware. You have an operating system to communicate with your hardware. When you buy a new laptop, you cannot do anything on the laptop unless you install an operating system. An operating system is a software which talks to the hardware, the CPU, the memory, the hard disk, the keyboard, the display that is installed on your laptop, and then allows you to interact with the hardware. Linux kernel directly communicates with the hardware. Then comes the shell. Shell is the user interface for the Linux kernel. So the shell has the ability to access Linux kernel commands. Now, let us come to the applications. Applications are a piece of software that is written on top of your operating systems. Many of the GUI tools are applications. Vim is an application, and all these applications interact with the hardware by requesting the kernel to run system commands. This is done via shell. So this is a typical operating system architecture. If you go on to further detail, we will see the architecture in detail here. We have the bottom line hardware here. So this is the hardware, this is the kernel, and this is the apps. Apps are always called users space. Apps do not have root permission by default. They do not possess systems level permissions as well. Kernel always run in system level. That means it can access all system level resources. So on kernel, there are some architecture dependent code. For example, if your underlying hardware has a Core i7 CPU, then in your kernel there will be a piece of code which will understand how Core i7 works and how to interact with your CPU. If your machine is i5, then it will have that particular piece of code. Thus, relevant piece of code is available in your kernel. Then comes the device drivers. Device drivers are responsible for interacting with your actual hardware that is connected to your system. So there may be a device driver for your hard disk or your SSDs or your keyboard. So they are all device drivers which enable the operating system to talk to the hardware. Then you will come across a lot of modules, and each of these modules will have its own function. For example, there is an init module which takes care of boot up of a Linux machine. There is a memory manager which manages your available RAM, pages, and direct access. All these kind of memory management is done by Memory Management Module. There is a network interface for connecting to networks like VFS for accessing your disks, IPC for inter-process communication, and Scheduler for scheduling processes with CPU. There is System Call Interface. System Call Interface enables interaction with the user space or the applications. So you use system calls to interact with various modules or with device drivers and then ultimately interact with your hardware. This is what a typical Linux architecture looks like. Now we're going to learn more about how do we manage a Linux system and how to configure a Linux system and what else we can do with a Linux system for getting optimal performance. Next in our DevOps course, we are going to understand some basic Linux commands and some basic operations in Linux. We are going to understand hardware interactions or hardware optimizations. We are also going to understand about CPU scheduling, memory management, debugging, and various tips and tricks in Linux. We are almost done with the session. I hope you enjoyed this video with us. Stay tuned for more videos on DevOps.